you will see on your name server a resolution request will appear for scott.attacker.com. So by seeing traffic like this, you know that the output of the query select user from dual was Scott. So if you try this attack in the Oracle 11g, then you will find that this will fail. That's because in 11g they introduced Oracle introduced network access controls, which stops execution of functions which could cause network access. So if you execute this function in Oracle 11g, you will get an error message saying network ACLs denied by access control list. So till like March this year, there was, well, at least I didn't know of any technique of doing out-of-band channels in 11g, obviously as a public user. And then I think David Litchfield released a paper in which he discussed use of an alternate function in 11g, which is DBMS underscore ldap.init, which again is executable by public. And you can use this to again create out-of-band channels and extract data. So this is actually quite interesting, and we saw that in a real breach case that so people are using a lot of IDSs and IPSs and they just don't learn the lesson. So by issuing query like this, then what you can do is you can make the database server do a recursive DNS lookup for every single row within the table. So if you had a table which contained all the credit card numbers, the first name and the last name of the card holder, then issuing query like this. So one query will go through the entire table and recursively issue requests for every single row. So basically with one query, an attacker can pretty much get the entire table which he wants. So all he needs to do is basically make sure that this one query bypass your antivirus, IDS filter. So we looked at this, and this was quite interesting to us. And we thought, okay, so we can issue HTTP or DNS connections to whatever network that database has access to. So we said, hang on a minute, what if we use this function to make HTTP request to the internal LAN and basically use this Oracle database as an HTTP proxy to browse the internal network which this Oracle database has access to. So using this function, you can essentially use your SQL injection as an HTTP proxy and then browse the internal network pretty much. And if you find any vulnerabilities on the internal network, then you can use this proxy to hack these components on the internal network. So what we are seeing quite a lot, or what I have seen quite a lot, is the Oracle database servers is often managed by third-party companies. So these database servers are in the third-party LANs. And in this third-party VLAN, you will have other components as well. So if on the internet you found one application which is in the DMZ, but it talks to an Oracle database server within the LAN, and that LAN has other components, so you can use that database to connect to other web servers, and then from that web server you can hack other database servers and get a connection out. So I actually have a small demo of this. So what we're going to be doing is, this is a simple Oracle SQL injection. In this, we are using the union to extract data from the database. So we simply do union select banner from $v version, and you will see it just displays the entire contents of $v version. Right. So now within the union, we call the HTTP URI type to browse an internal website, which is located on 2.51. And you will see the HTML response from the internal website. And so this is an ASP page on the internal VLAN, which is connected to the Oracle database. And possibly this ASP page is talking to an MS SQL server. So we pass a parameter QID is equal to 1. And we see the content of that ASP page for QID is equal to 1. Next, what we do is we try to inject a single quote in the URL for the ASP page and see if it gives us any error messages which could correspond to a possible SQL injection in the ASP page, and it actually gives an error message. So we know that even the ASP page, which is hosted internally, is vulnerable to SQL injection. Then what we do is we exploit this internal ASP page, which is vulnerable to SQL injection, and we do an at version, and we basically dump out the SQL version from the Oracle, from the initial Oracle entry point. And basically, with a little bit more innovation, you can completely compromise that internal MS SQL server by calling the XP_CMD shell from the Oracle proxy. So we make a netcat listen on port 4444, and using the Oracle as SQL injection as a proxy, we then call XP_CMD shell to throw us a reverse shell from MS SQL onto somewhere on the internet. This is where we are capturing shell. Right, so there you go. So you can use that proxy to hack internal networks. So yeah, so that was the demo done. Right, so the next part was privilege escalation. I mean, this is something which is not very well defined, and this is some sort of my terminology. So what I mean by this is, so you have a SQL injection, and you are injecting something into the SQL injection, possibly some query to for which you want the output of. Now, so whatever you have injected within the SQL injection, with what privileges that particular thing you have injected gets executed is something which interests me. If that gets executed with the privilege of a high privileged user, I will call that my SQL injection is privileged. If whatever I have injected gets executed with the privileges of a low privileged user, then I'll call it as an unprivileged SQL injection. So no brainer really. Okay, so privileged SQL injection. There can be a scenario where you are injecting something, you found a SQL injection, and you found out that your current privileges are that of a DBA. Now, that can happen under two scenarios. Either the application connects to the database server as a user who already have a DBA role. Just like, I mean, it's not very uncommon nowadays, even nowadays, to see ASP applications or ASPX applications connecting to MS SQL with SA privileges. So we do see that every now and then, app connects to the database with DBA privileges. But more popularly, what we see is SQL injection is in a procedure owned by a DBA. So even though the application may connect to the database as an unprivileged user, but the injection point is actually in a procedure which is owned by a DBA user. So your SQL injection is privileged, even though the application connects as an unprivileged user. Or second case could be that it's a simple SQL injection, app connects as an unprivileged user, and you don't have higher privileges really. So a good analogy to understand what I meant by privilege escalation is again comparing it with MS SQL. Those of you who have read Chris Anley's paper on privilege escalation, essentially he used openrowset to brute force the SA password in MS SQL, and if successfully brute force, then he can issue queries with SA privileges. So I wanted to achieve something similar in Oracle, but unfortunately it's not that straightforward. So you remember I talked about the limitations in Oracle SQL. The limitation was that we cannot call procedures, we cannot call vulnerable procedures, even though Oracle database might be outdated because of the limitations in SQL. What you can do, and what's your best option, is to call functions within the SQL, because you can call functions. Some functions are supported in SQL. And your best bet is to call vulnerable functions and then exploit these vulnerabilities within the function by calling them in the SQL. So get domain index tables was one such function. This function was vulnerable to PL SQL injection. So what we do is we call this function within our SQL, which we can call, and then as an argument to this function, we pass PL SQL. So basically that means that you are basically converting a SQL injection, in this case, to a PL SQL injection. And if that happens, then again, you have no restrictions. However, this is an outdated exploit really. I mean, this was patched in 2006. I mean, if you are exploiting the SQL injection against these versions, then you can use this exploit. This is how the exploit looks like. So you can issue a query like this within your SQL injection, and that will grant DBA role to public. and then basically every user is a DBA user, and then you can exploit or extract data from the database with DBA permissions pretty much. So again, this exploit is something which is quite popular in all the tools. If you look at commercial tools, even Pangolin, even I think some other tools, they rely on this exploit, which in my opinion is quite outdated now. So it's not like this is the only function which we can call, and after 2006 the privilege escalation vector does not exist. There are functions which have been reported after 2006 which were executable by public, and they were vulnerable to PLSQL. Hang on. So yeah, sorry. This slide was about the same exploit. Yeah, there are a few such functions known, but the exploit is not public. For example, a function in the package DBMS Java 10, that function was vulnerable to buffer overflow, and that was patched in July 2007. So technically, you can call that function within your SQL and carry out a buffer overflow from web applications and still compromise the server, but the exploit code is not available, at least to me. So we're going to skip that part. Coming back to the OS, so now coming to the OS code execution, in what conditions can we execute OS code against the remote database server? Again, we can have two scenarios really. Is our SQL injection privileged or not privileged? If it's unprivileged, then we go back to the same exploit, which I showed, which was patched into 2006, and that lets us execute OS code. However, and this is actually quite interesting, if we have two privileges, if we have DBA privileges or Java IO privileges, then again we can execute OS code. So think of it like a feature really. I mean, even to call XP_CMD shell in MS SQL, your connection user should have the sysadmin role. Even then, he can call XP_CMD shell. So similarly, in Oracle, if you want to execute OS code and you had these two privileges, either DBA or Java IO, then you can execute code. So again, DBMS export extension, which I showed earlier, this was a function vulnerable to SQL Injection, which lets you execute OS code. I will be later showing the demo of a tool which is which I wrote, which is called BSQLBF, which supports this mode of exploitation. Yeah, basically you can do stuff with that. So, I mean, that exploit was patched in 2006, and that does not interest me anymore. But what does interest me is if my connection string user has Java IO privileges, then in that case, there are two functions. There is a run Java function, which is available in 11G, R1, and R2, which you can call to directly execute OS code. Or there is a function called funcall, which is available also in 10G, R2, 11G, R1, and 11G, R2, which you can use to call to execute OS code. Now, both of these functions, they require an Oracle class to be present, which you can, so you need to pass as an argument to this function an Oracle class, which has a method by which you can execute OS code. And David Litchfield actually showed that this particular class, which ships with Oracle by default, has the main function, and that main function lets you execute OS code. So simple as that. If my connection string user has Java IO permissions, then I can just call this function, and as an argument to this function, give this class the method main, and the argument to the main method, whatever code you want to execute on the remote Oracle database server. So if you had DBA privileges, then obviously it's a lot easier, because a DBA is like a higher privilege than Java IO permissions at least. So if you have DBA privileges, then we can again execute OS code. The trouble is that if you grant yourself Java IO permissions, then those permissions are not available in the same session. So you can technically, the application will log you out and log back in, and maybe in the second or third request, you can go back to Java IO exploit and use the same technique again. But an easier way is available. What you can do is, there is a function in